Okay, so welcome back. Okay, so now let's talk about another way we could represent component vectors, especially when it comes to direction, using the direction of the vector. So let's use this as an example. So we've got this vector v, and it terminates at the point, and we're looking at the rectangular coordinate system, right? The rectangular coordinate plane xy. And so we want to describe this vector in terms of the angle that it has with the horizontal. Okay, and so how do we represent this as an angle to the horizontal? Well, it's exactly the same way we did it when we were dealing with polar coordinates. Okay, so if we know the component vectors, right? So I'm not going to draw the component vectors, but I'm going to draw them this way. So let's say we have one component vector here. Okay, like so. And so now, with polar coordinates, we had what? Y, X, and R. Well, instead of R, right, R is the magnitude of this vector. So instead of using R, now we're going to use the magnitude since we're dealing with vectors. So the length of this vector is given by the absolute value of R. So we're going to use this, so this is going to be y, this is going to be x, and then this is going to be the magnitude of v, magnitude of the vector. Okay? And so now, what can we do? We can represent what? Cosine of theta is going to equal what? Cosine of theta is going to be x over the magnitude of v. And then sine of theta is going to be represented by y over the magnitude of the vector v. Okay? Now, what does this mean? It means that we can represent x equal to the absolute value of v, or the magnitude of v, times cosine theta, and y is equal to the magnitude of v sine theta. Right? And so now that gives us a way to be able to write the vector using the angle, the direction. Okay? Now, that means that what? So again, see, this is in standard position, so let me back up a little bit. So v, so let me write here, v is equal to x comma y, right? So there's the vector, it's a position vector. Okay, now, how do we represent this? Well, we represent the vectors in the component forms as what? Well, remember, this means that v is what? It's going to be x times what? 1 comma 0 plus this vector, which is going to be y times 0 comma 1, which just gives us x, not j, x sub I, or xi plus yj. Okay, now we can substitute in x and y, and guess what? We can represent the vector as the magnitude of v times cosine theta. Okay? And so I'm going to put instead of I there, I'm going to put it in between. So it'll be the magnitude of V I cosine theta plus the magnitude of V J sine theta. Okay. Now you could put the I here and the J here if you want. I just put it in front because just so it doesn't get confusing, or students don't think that don't make the mistake of thinking that it's with the angle. Okay. But again, you could put it in the other way as well. And then of course, don't forget what's magnitude, right? The magnitude of V is just going to be the square root of x squared plus y squared, right? Using the Pythagorean identity. Okay? So that's how you do it. So there's another way to represent. So you can calculate in the component form of a vector using direction. Okay? So now you can represent a vector in terms of its magnitude and the direction. Have a great day.